Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Rabi Abdullah, and today I will present our assignment, which is the optical communication with our group members, which is Darwin and Muhammad Alham. For abstract, for gigabytes and beyond gigabytes transmission of data, fiber optic communication is the ideal choice. This type of communication is used to transmit voice, video, telemetry, and data over long distance and local area network or computer networks. A fiber optic communication system have used light wave technology to transmit the data over fiber by changing electronic signal into light. Some exponential characteristic feature of this type of communication system, like large bandwidth, small diameter, light wave, long distance signal transmission, and transmission security, and so on, make this communication a major building block in any telecommunication. The subsequent information on fiber optical communication system highlight its characteristic, feature, basic element, and other details. In the introduction, fiber optic communication is a technique for transferring light plus across an optical fiber to transport data from one location to another. The electromagnetic carrier wave that the light creates is modified to transmit information, where great distance, high bandwidth, or immunity to electromagnetic interface are necessary. Electrical cabling is used. Voice, video, and telemetry can be transmitted using this method of communication through short and long distance network, as well as computer network. Many telecommunication providers employ optical fiber to deliver cable, television signal, internet communications, and telephone signal. Bell Labs researchers have used fiber optic transmission to achieve the internet rates of more than 100 bits per kilometer per second. The following fundamental steps are involved in fiber optical communication. First, using transmitter to create an optical signal from an electrical signal. Second, relaying the signal through the fiber while watching out for too much distortion or deterioration. Third, taking talking in the optical signal for creating an electrical signal from it. For the lecture review, fiber optical transmission includes the transfer of signal in the form of light from one place to another is contrast to copper wire based transmissions, where the transmission completely depends on electrical impulse traveling through the cable. A fiber optic communication network also includes light source detectors like those in the illustration, transmission and receiving electronics and other components. When the transmitter successfully receives the input data in the form of electrical impulse, it transforms them into light signal with the aid of the light source. This source is an LED, and for effective transmission is amplitude, frequency, and phase must all be constant and unchanging. A fiber optic cable carries the light beam from the source to the destination circuitry, where a receiver circuit converts the data back into an electrical signal, which show the in the figure. The receiver circuit, which can measure the amplitude, frequency, and phase of optical field, is made up of a photodetector and a suitable electronic circuit. The frequency used for this sort of communication are slightly above the visible spectrum, close to the infrared region. Depending on the application, either an LED or a laser can be enlisted as a light source as a light source.
I will continue the presentation with the methodology part. The term optical communication refers to a communication technique in which a signal is delivered as light, with optical fiber serving as the medium for doing so. A signal delivered by an optical fiber is transformed from electrical signal into light, which is then converted back into an electrical signal at the receiving end. And then the data will transfer across great distance that can be in the form of audio or video. Optical fiber communication has been applied for different communication objectives because of its success in long distance and high speed data transport. Other than that, the laser light is a signal wavelength light source. Specifically, laser light employed for optical fiber communication, while other light signals, like sunshine or light from above, contain many different light wavelengths, which make them less effective for communications. The advantage of optical fiber is first is extremely high bandwidth. The bandwidth provided by fiber is unmatched by another cable-based data transmission medium. Secondly, the advantages is longer distance. Compared to copper cables, optical cables used in a fiber optic transmission are capable of delivering little power loss and allowing signals to travel further. Next is the resistance to electromagnetic interference. The presence of setting like power substations, heating, ventilations, and other industrial source of interference is unavoidable in the deployment of practical cables. But because fiber is resistant to electromagnetic interference, it has a very low bit error rate. Next, low security risk. The usage of alternative raw materials and growing awareness of data security issues are the primary factors driving the growth of the fiber optic communications. This fiber optic transmission uses light to transport data or signal as an energy that leaks via the connection to listen in on the data being communicated, guaranteeing the complete security of information. The next advantage is the small size of fiber optic. The diameter of fiber optic cable is quite tiny. For instance, a single or M3 multi-mode fiber has a cable diameter of approximately only 2 mm, which is less than of coaxial copper cable. Another advantages is fiber optic has a light weight. Fiber optic cables are thinner than copper wires and construct of glass or plastic. As a result, they are lighter and simpler to install. Next, and lastly, easy to accommodate increasing bandwidth. The infrastructure of Existing cable systems can be expanded with a new equipment by using fiber optic cable. Because with a new equipment by using the fiber optic, compared to conventional cable, optical cable can offer considerably increased capacity, and fiber lines can accommodate the addition capacity thanks to WDM, which is wavelength division multiplexing technology. The disadvantage of fiber optic is difficult to install. Fiber optic cable splicing is difficult, and they will crack if you bend them too far. Thus, fiber optic is quite likely to be cut or damaged while being installed or constructed. Secondly, is attenuations and dispersion. Light will attenuate and spread as a transmission distance increase, so they necessitating the addition of more optical components like EDFA. Thirdly, the disadvantage of optical fiber is the cost is higher than copper cable. Installing fiber optic cable is still more expensive than installing copper cables, despite the fact that fiber optic installation costs are decreasing by as much as 60% annually, since installing copper lines does not require special care like installing fiber cables. The last disadvantage is special equipment is often required. Some specialized equipment is required to guarantee the fiber optic transmission quality. For instance, expensive specialized optical test equipment like optical probe and power meters are needed at the majority of fiber endpoints. So, this equipment is known as OTDR, which is optical time domain reflectometry.
Hello, my name is Dashwin Analagi Magisuran. My matric number is B0822102007. So I'm from 1BEDT. Today I'm going to discuss present about discussion. So the first one is multi-wave length fiber laser. Due to its use in optical communication, instrument testing, optical signal processing, and sensor applications, multi-wavelength fiber lasers are of great interest. The use of numerous laser diodes at various wavelengths is expensive and inefficient. Moreover, multi-wavelength sources offer an affordable and effective substitute. In addition to being more compact, it uses less energy and produces less heat than system using several laser diodes. Different techniques have been used to demonstrate simultaneous multi-wave oscillations based on an erbium doped fiber (EDF) lasers. For instance, phase shift fiber Bragg gratings, Fabry Paratones, and Sagnac loop filters, multi-wave length Raman fiber ring lasers, and cascaded long period fiber gratings. This is crucial for use in WDM system with a constant grating pitch. There have been proposed and demonstrated a number of Raman fiber lasers based on simple Bragg and gratings. Versatile and straightforward, SBG was successful in creating multi-wavelength source by adjusting the operational wavelength channel spacing with high B fiber loop mirror. A multi-wavelength EDFL was also demonstrated. They have successfully developed a unique multi-wavelength lasing technique using an SB fiber laser and Sagnac loop mirror with increased Brillouin 4-wave mixing. The laser runs at 34 multiple stoke lines with an anti-stoke of 0.08 Newton meter. Thank you. So as for the second discussion, Brilliant fiber laser. In addition to the other techniques described in the previous section, the multi-wave length combined can be produced by the Brilliant or erbium fiber laser (BEFL) simulated Brilliant scattering effect (SBS). The production of multi-wave length fiber laser using a BEFL is the main topic of this discussion. To provide high back propagating Stokes power and Brillouin gain in the cavity, the BFL can be set up so that the SMF or PCF receives more Brillouin pump power. Because of their uniform gain and limited bandwidth, have the property of having a narrow line width. Because of the tiny magnitude of Brillouin gain, the conventional method to create a Brillouin fiber laser is to build a critically coupled resonator, which necessitates achieving threshold in a BFL for a resonator pump over power, while still deriving lasing action from the non-linear Brillouin gain. An Ibrahim doped filter amplifier in a laser cavity of BEFL compensates for the resonator loss that is crucial in a conventional BFL. Applications include coherent optical communication, coherent LiDAR detection, fiber gyros, and sensors all require coherent laser sources with minimal intensity noise. Thank you.
As for the conclusion, optical fiber technology has evolved in many courses such as like engineering, medicine, photonics, and also telecommunications. It is because it has low loss and also lack of interference. Not forget about larger bandwidth and also inherent high data carrying capacity. It has drawn the attention of numerous researchers. Despite the fact that optical fibers have a number of benefits, there are still some drawbacks to the technology. And despite the fact that sand, the material used to make optical fibers, is naturally abundant, one drawback of optical fiber is that they are more expensive than copper connections. Another drawback is that optical fiber mounting requires highly trained labor. I think that's all from us. Thank you.